Analytics. I am T. Shiva, Assistant Professor from Department of Computer Science and Business Systems, Thiaraja College of Engineering. In today's lecture, we will dive into advanced centrality measure and influence scoring techniques, which helps us understand how influence, information flow, and authority emerges inside social networks. These concepts are essential for influencer making, viral content prediction, and community analysis in modern digital ecosystem. So in previous session, we explored network basis, node, edges, types of ties, and fundamental centrality measures like degree and betweenness. Today, we are moving to more advanced topic that model recursive influence, weighted network, and time-hour interaction. Here are the key topics we will cover today. Eigenvector centrality, which used to understand the influence based on connections to influential nodes. Cat centrality, incorporating indirect influence and giving baseline values to isolated nodes. Hubs and authorities, identifying good information source and credible design destination. Super spreaders and gatekeepers, modeling viral diffusion and information control. Weighted and time aware centrality, incorporating real interaction strength and reasonness. Influencer targeting application, how marketers use these metrics in real world campaigns, and two small problems as an example for calculation practice and a small quiz to reinforce the concepts. Let's get started. So advanced centrality and influence scoring. Eigenvector centrality is a recursive influence measure. The central idea is a node is influential if it is connected to other influential nodes. Unlike degree centrality, which only counts connections, eigenvector looks at the quality of those connections. If celebrity follows you, this connection increases your score more than a connection from a low influencer user. Eigenvector centrality. The formula for eigenvector centrality is EC of I equal to 1 by lambda summation of Aij into EC of j. Here Aij indicates whether there is a link between node j to I. EC of j is the influence score of node j. Lambda is normalizing factor. The real world use case of this particular thing is Google's early PageRank algorithm is a variant of eigencentrality used to identify option leader on Twitter and Instagram, helps detect the leaders or authoritative voice in any domain. Cat centrality. Cat centrality extends the eigenvector centrality by giving credit to indirect connections. It also ensures isolated or less connected network gets a small positive score. The formula which is used for cat centrality is EC of I is equal to alpha into summation of Aij Kc of j plus beta. Here alpha is alternative factor, weights demands for long path, beta is the baseline value given to every node. Why is this important? Because real social network contains many users who have low degree but still produces meaningful contributions. CATS allows marketers and analysts to spot emerging influencers early, even before they accumulate many followers. Hubs and authority. The HITS algorithm classifies node into two roles. One is hubs, another one is authority. Hubs means nodes that points to many high quality resources. Example, a website that links to many trustworthy sources. Authorities, nodes that are heavily linked by good hubs. Example, credible medical websites receiving citation from many research bloggers. Why it is important? Hubs helps user discover information while authorities helps user trustworthy information. Platforms such as recommendations engine utilize hits for ranking their resources. Super spreaders and gatekeepers. Let's now connect centrality measure to real human behavior in a network. Super spreaders, these are nodes that can trigger large viral cascades. They often post frequently, have highly responsive audience, and connect to multiple communities. In marketing, identifying super spreaders means identifying the best node for seeding a campaign. Gatekeepers control information flow between communities. They may not be the most followed nodes, but they occupy crucial position in a network structure. Example, a journalist connecting two political groups, a content curator connecting two interested based communities. Gatekeepers are critical in minimizing misinformation spread and improving targeted outreach. Weighted and time aware centrality. Weighted centrality. The edges are assigned weights based on interaction strength, message frequency, comment or likes activity, shared content relevance. Heavier weights are stronger influence. In time aware centrality, networks interaction decay over time. A like from yesterday is more relevant than a like from 3 months ago. A decay function ensures recent activity has higher importance. This is extremely useful for tracking trend movement, monitoring influencer engagement, real-time recommendation systems. Influencer targeting applications. Centrality measures help brands identify authority influencers, core creators across multiple metrics, and support marketing decisions. Identifying authority influencer, not just high follower count, it identifies the actual influence. Score creator across multiple metrics, platforms uses centrality to detect quality leaders. Support making decisions, who to collaborate with, who can maximize campaign reach, how does influence evolve over time. These quantitative methods make influencer more marketing more scientific and data driven. Now let us see few problems around to these topics. The given adjacency matrix A, which contains 0 1 1 1 0 0 1 0 0. The solution is the node 1 is adjacent to 2 and node 2 is adjacent to 1 and the node 1 is adjacent to 3. So if you form a 2 cross 2 matrix, if you form a 3 cross 3 matrix using this particular given value, you can identify the linkage using the 1 available. Wherever the 1 is available, that particular node is, there is a linkage between those two nodes. Node 1 receives influence from two nodes highest rank, and node 2 and 3 have fewer incomings influence, so they too have equal score. So the node 1 has the highest rank among all the 3 nodes. So next, problem 2. In problem 2, a chain structure is given. This A is linked to B and B is linked to C with alpha is equal to 0.1, beta is equal to 1. The solution is Kc is equal to 1, Kc of B equal to 1.1, Kc of C equal to 1.11. So the influence accumulates along the chain because each successive nodes receive influence from previous one plus baseline value. So let's wrap up these ideas. So first we have seen about the eigen centrality captures recursive influence, and cat centrality supports indirect influence and isolated nodes. Hits distinguishes hubs and authorities. Super spreaders triggers information cascade. Gatekeepers regulates community level flow. Weighted and time over centrality and realism by incorporating strength and recency. These methods are more powerful tool for influencer identification, content strategy, and marketing analytics. Now let us see a quiz questions on this topic. First question: eigenvector centrality rewards nodes that are connected to dash. A node with high degree only, node with high influence score, isolated node, random neighbors. And the answer is nodes with high influence score. Second question: which centrality measures assign a baseline value of beta to all nodes? Option A, eigenvector centrality. Option B, betweenness centrality. Option C, scarce centrality. And option D, closeness centrality. The answer is scarce centrality. Third question: in the Hits algorithm, a good hub is defined as the node that dash, that has highest degree, that has points to many strong authorities, that connects to two clusters, receives links from many nodes. The answer is points to many strong authorities. Fourth question: gatekeepers are important because they have the highest number of followers, controls information flow between communities, are always super spreaders, have strong authority score only. And the answer is controls information flow between communities. Fifth question: time aware centrality gives more weight to old connections, shortest path only, recent interactions, and random interactions. The answer is recent interactions. So now we have come to the end of this particular session. In the last video, we have explored about the deep dive into social influence diffusion. Today we have seen about the advanced centrality and influence scoring. In the next video, we will explore further about the temporal and dynamics network. Thank you.